Our class today will be on correlation analysis. This is where we're going to look at how the dependent and independent variables are related. So we are going to learn how to come up with regression equations and also tell the relationships, whether they are strong, whether they are weak, and whether they are there's no relationship at all. So relationships can come in negative, positive, or no relationship in a vertical line and a horizontal line. Okay, so this is one of the easiest topics that this course has, and I need your attention very well. So I said correlation is a technique that we use in statistics to do what? To measure the strength and direction of the relationship between two variables, being the dependent and independent variables. And this is widely used in finance, in economics, as well as for decision making. So relationships are as follows. We have a positive relationship and we have a negative relationship. The positive relationship R, okay, is when you have greater than when you're greater than zero. Okay, when your R is greater than zero, this is a positive relationship. When your R is less than zero, it's a negative relationship. Okay, then when your R, we square it and it's more than 50. This is a what? Is a strong relationship. And R squared is what? Greater than, less than 50. It is a weak relationship. So relationships can come in these two forms. So we have correlation analysis with the purposes of determining the relationship between two variables, the price and the demand, the X and the Y. So that is the use of the correlation analysis. So it is also used to input the regression for forecasting purposes, where Y is equal to what? A plus what? BX. Okay? So A is the cutting point on Y. B is the slope of the equation. Okay, so the correlation analysis is a statistical technique that is used to measure the strength, which is R squared. R squared is the coefficient of the determination. And the direction. The direction is simply the coefficient of correlation, okay, which is given by R. R is given by summation of what? X, Y, minus summation of X times summation of Y. Then we put our N here over the square root of what? N summation of X squared minus summation of what? X to the power what? The power 2. Then also, this is called the variation of X. And N summation of X squared minus, oh, this is Y in this case, the variation of Y. Y squared minus summation of Y to the power 2. So one is in brackets and one is not in brackets. So the correlation will range between -1 and +1. So the closer to 1 we are, the stronger the relationship. So if you get exactly 1, it is a perfect positive relationship, meaning both variables increase together. If there is 0, it means you have a horizontal line. There's no relationship at all. So R is equal to 0. When you have -1, this means you have a what? a negative relationship. Perfectly negative relationship. Okay, are we together? So now, with that being said, when we get our answer and we square it, it's simply R times R, it's coefficient of determination. It gives you the strength of the relationship. If we get our answer, for instance, as 0. What? 89. So it means that what? We have 81% relationship, strong relationship. Any questions so far? Then the regression equation is given by y is equal to a plus bx. So the b is a slope. It is similar to r when you're calculating it. It is given by n summation of xy minus what? Summation of x times what? Summation of y over the variation in x, which is summation of x squared minus summation of what? X to the power 2. So this is what we call the variation in x down there. Okay, so let us now um, calculate the value of a. The value of a is simply the mean of y, which is summation of y over n, minus b, then the mean of x, summation of what? X over n. So this is what will make you get the 20 marks. When you see the exam, this should be the easiest. All right. Then suppose you're given values of x and y. We have 1, 2, 3, 4, and 5. And the values of y, 1, 2, 2, okay, 1, 1, 2, 2, and 4. So let us illustrate this to show that it's a positive relationship or negative relationship. So our x is here and our y is there. So we have what? Y here and x here. So here we have 1, 2, 3, and 4 on the x and what? 5. And on the y we have 1, 2, 3, 4. So plotting this, we can tell the relationship that we have 1 on 1. Okay. Then the next one is what? 2 against 1. Put it here. Then the next one is what? 3 against 2. And also 4 against 5. So this is showing you what trend. Is it a positive relationship? Yes. So positive relationship is upsloping. And they're close to each other, meaning their R is strong. Are we together? So in that case, we now get to business, to calculating these particular values. Are we together? Now, how do we calculate the R and how do we calculate the B and how do we find all those figures? Okay, so we'll fill in this table to calculate those particular figures as follows. X and Y columns can be written in that order. So bear in mind that the most important formula that we need to understand is the Pearson's correlation coefficient formula. There are many formulas that will be given. Can be given this formula or that formula. the answers basically will be the same. Okay, let me give you what I feel is simpler to remember. xy here, and x squared and y squared. By the time I'm done with this one, you should be able to do the term project. That one is coming in the exam as your homework. So 1, 2, 3, 4, and 5. I've been using this simple formula throughout with the same figures so that it's easy for you to understand. Then here we have 1, 1, 2, 2, and 4. So when we apply these two, here we have 1, here we have 1. 2 times 1 is what? This is
Your call cannot be completed.
This is 2. Then this is what? 6. Then this is 8. Then this is 20. This, we are squaring the x's here.
How are you?
Are we together? Have I lost anyone so far?
Okay. Kandai.
Please mute yourselves.
He returns.
D, mute
So,
yourself. And your videos, please mute your videos. All right. So far, are we together? So x squared here we have 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is what? 25. Then we go here. The y squared is 1 and 1 and 4 and 4 and 16. So let's total up here. What do we have? What do we get on the totals? Summation of x here, summation of y here, summation of xy, okay? Summation of x squared, summation of y squared. So the totals here are what? We have 15 here. Here we have 10. Here we have 37. Here we have 55.
55
And here we have
and
26.
26.
All right. So using this in a calculator, it can produce everything for you as quickly as 1 to 3 if you want. So we'll learn that later on. So for now, because it's a baby class, Kaunda, are we together at this point? Are we together so far?
Yes.
So our n is what? We count the number of hairs. 1, 2, 3, 4, 5. Our n is 5. Okay. So R, we said R, what was the formula for R? N summation of what? xy minus what? Summation of x times what? Summation of y. Then down here we have what? The summation of the variation in x and the variation in y. So what is the variation in x? Easy, just put n x squared minus x to the power 2. Here we have n summation of y squared minus summation of what? Y to the power 2. So what was our n? 5. Summation of xy? 37. What is
7.
summation of x? 15.
15.
Summation of y? 10.
Okay.
Somebody to send me the first 10 projects so that we also quickly have a look at it in this simpler manner. All right, then here the variation in x, what is summation of x squared? 55. Minus x squared, 15 squared. Okay, so that is for what? For the variation in x. That's the variation in y. 5. Summation of y squared, 26. Minus summation of y to the power 2, 10 to the power 2. Okay, all together with the computation here. So we're going to get a 0.903.
Yes.
What is the interpretation of this? We're just interested in the sign to find the direction. It's a positive, so meaning there's a positive relationship. If it was a negative, you say there's a negative relationship. Okay, is that clear? All together?
Yes. Yes.
All right. Then what did I say was the slope? The slope is half formula of R. So slope is what? Before I go to slope, R for the direction, then R squared is for the strength. So just multiply this answer. We divide it by what? We power it to 2. 0.903 squared. When square it, we're going to get what? 0.816. This means 81.6% of y is because of x. It's because of x. Okay. All right. Is that clear? Just an issue of squaring it. Then our b, which is a gradient. How do you find the gradient? Summation of what? X. The top part here, y. Minus summation of what? X times
Summation of xy.
times summation of y. All right. Over what? Variation in x, summation of x squared minus summation of x to the power 2. Okay. So what do we have here? 5 on that what? That's 7 minus 15 times what? Times 10 over this part on x only. 5 times 55 minus what? 15 squared. What do we get? When you compute this, what are you getting? 0.7. So we know that our regression equation is equal to a plus bx. And our b has already been found. So we'll just substitute where there's b, we put our 0.7. We can find our a. Our a is dependent on the answer we found on b, summation of y minus b, summation of x over n. So in this case, summation of y is what? From this column is 10. 10 over 5 minus the b we just found there. So if your b is wrong, a is affected. You can see that, right? And 15 over n is 5. So when you compute this, we're going to get negative 0.1. So this is what we put on our A. So y is equal to negative 0.1 plus what? B 0.7 times x. So this becomes our regression or the prediction equation. Are we together? Are we together? Okay. So we are done.
Sorry, can kindly repeat from um after we got the R squared.
So after we get to r squared, we get 0.816. So this is just multiplied by 100. It simply means 81.6% of y is because of x. Okay? Is that clear?
Yes.
Then we go to calculating the regression equation a plus bx. So to find that, we need to first find b. b is n summation of xy minus summation of x times summation of y over n summation of x squared minus summation of x to the power 2. So our n is 5. So in short, we're just getting the entire part here and just this part for x without the square root. That is our that is our formula. So when you compute this and put them in there, we discover that you're going to have what? You're going to have the answer for our b, which is 0.7. So 0.7, you put it here. Now we need to find our a. Our a is summation of y over n minus b, summation of x over n. So 10 over 5 minus 0.7, 15 over 5. So the answer we're going to get is negative 0.1, which we put on the a. Negative 0.1.
Well, it's just a question. Why aren't you including the y's on the calculation on B?
Why am I including the y on the calculation? There's no y
Why
on
are
B.
you not? No, why are you not including?
It's a
Just
formula.
after the calculation, huh?
That's how the
Second
formula
calculation.
is. Yes, this is it's a
Okay.
formula itself. Yeah, that's how it is.
But I've seen the y in the formula. Isn't it b n summation of xy? Or maybe I just didn't understand that.
B was given by what? B is equal to what?
B is equal to n summation of xy
Mm-hmm.
minus summation of x
Mm-hmm.
multiplied by summation of y.
Mm-hmm.
Yeah.
Over. It doesn't end there.
Over.
Mm-hmm.
Yeah,
Over.
no, it doesn't.
Over
Then down we
n
have
summation of
n.
x summation of x squared over summation of x squared n x squared minus summation of x to the power 2. This is a whole formula. Mm.
These formulas are given in an exam, right?
Yes, yes.
Just for it to-
Yes, they are given in the exam, yes. Okay.
So is it similar to the formula written on point 3? Or it's another different one?
Yes, it's similar here. Except here you first need to calculate the mean of x and subtract from each of these ones here. There are 3 different formulas that you can use. Okay, I love this because it's easier for you for exam purposes.
Okay.
Yeah. Any other questions?
Excuse me. You
Mm-hmm.
said after finding the regression, the R there,
Mm-hmm.
you also had to find the R squared.
Mm-hmm.
What is it meaning, the R squared? I think I missed somewhere.
R squared means what? Means coefficient of determination. It measures how much of the dependent variable is affected by the independent variable. In short, how much of X affects Y. If you're dealing with sales and advertising, if you get 0.9, it means 90% of the sales are coming from advertising. So it measures the strength of the relationship that emanates
Okay.
from there. Are we
Okay.
together? So if you have
Yes,
above
yes.
5, it means that is a strong relationship. If it's below 5, it means it's a weak relationship. Okay.
Okay.
Any other question? Any other questions? Please speak now or forever hold your peace.
Kindly just go through the y is equal to a plus bx.
Y is equal to a plus bx. So this is a prediction equation that is able to tell you how much of one variable is. So they ask you to find the equation itself. So to find this equation, you first have to find the b. B is what we're calculating here. So n, all these formula, when substitute these, they're coming from here. We find our b as 0.7. So where there's b here, put 0.7. Leave the x and y as it is because they're part of the equation. 0.7, what? X. Then we go to finding a, which is the y-intercept. Summation of y over n, so 10 over 5 minus the b, which is 0.7, the slope which we just found here. So this slope is important. If you get it wrong, you get it wrong here. Then summation of x, which is 15 over 5. So when you compute this is 2 minus 0.7 times 3. We get the final answer as what? Negative 0.1. So 0.1 here, you put it there. The next question they ask you, find y if x is equal to 10. Find y if x is equal to 10. So you substitute there. It may not always be 10, it can be applied, okay? Find the sales if advertising is 5 million. So since your x, is maybe your advertisement, you put where the x, what values has been given to you. So put our 10 here. So our answer here is going to be 6.9. If those were millions, you would put them in that context to predict them. So one of the jobs of the regression is to predict. Okay, one of the jobs of the regression is to predict. Are we together?
Okay.
All right. So if we're going to look at our term project, it will give us something to think about here. Okay, this is a question, it's coming in the exam, so you need to know this. Question number 4. All right, so you know what to do now there. What is your x? What is your y? And how do we calculate those things? So I need those answers by before our evening class at 21 or 22. Find our x. We've also been given the other computations. So that is our homework for today. Find the coefficient of determination. This is 20 marks. I repeat, it is coming the way it is exactly. So you just need to calculate it and understand. Are you together?
Yes, actually this makes more sense than when we were just handing in the project.
Oh yeah,
It's now makes sense. I can get the meaning and see the sense out of the question. Thank you very much.
appreciate, yeah.
I just need help on the it says if the coefficient of determination significant, explain. Oh, it will be in our answer. Okay.
Yes. With your answers. So please take your time and apply them step by step. I want you to really appreciate that what we are looking at is what actually comes. So I'll be checking on your works. I know someone should have helped you do 1 or 2 things, but now you'll be alone in the exam. All right? So please,
So true.
let's
Please
do
post the
this.
escape question for us to be quick.
Yeah, so it's the easiest when it comes. Please be quick to rush to it. Okay? just to lead you through examples of what you must look out for. You must have this column, obviously. Due to time for physical clients, I take them through how to enter them in the calculator. So you're going to have X and Y. You find these totals there. Okay, you know where we're coming from, isn't it? When you do that,
Yes.
right, you find what? The summary totals. Okay, using the formulas, which he'll give you. Now, depending on the formulas that he'll give in the exam, you might be limited on what formula to use. So I'd rather you understand the formula I'm giving you here. Okay, then you get the summary totals and you put them down there. These ones, you fuse them in the formula that you may have. So I don't know what formula you are familiar with, but I advise that what you're familiar with is what you do, what you use. All right. Then coefficient of that determination, I said it has many formulas. All right. So R squared can be calculated according to the formula that you would want. Others would use this formula. Others would use the formula that I gave them. All right. So I will expect some good work from you. So we'll end here. Thank you so much for your time.